Hello everyone, welcome to Super Coaching UPSC by Textbook. This is Venkatesh, your faculty for Geography. So my dear aspirants, in the last few months, you might have seen how the teleconnections of El-Nino and La Nina, you might have heard about these events. You might have seen how this will have a cascading impact on climate across the world, be it the western disturbances which are impacted by El-Nino this year, be it the lack of snowfall in Jammu, right? Or else in general about the weather conditions of monsoon. El-Nino is very much associated with all the weather events across the world. So as we discuss that, so to solve all these things, today we'll be discussing about all these events. I hope you all able to participate this in a good way. You are able to understand the topics associated with El-Nino, right? So let me see any audio issues are there. Is that okay? Okay, right. So when you talk about El-Nino and La Nina, what are these things? These are nothing but the events which you have seen in the Pacific Ocean, or this is a circulation of the impacts of temperatures in the Pacific Ocean. Before we tell you about that, let us have a brief background. Now have this background while you discuss about a topic called El-Nino and La Nina, right? Have this as a background. What is the background? The background is this. We know that normally because of insolation there is unequal heating on the Earth's surface. Because of unequal heating there is a variations of temperature variations that will lead to having a variations of pressure conditions. Variations of pressure will lead to movement of winds. Winds with moisture carry rainfall, right? So we have a climatological background. Insolation is the topic, unequal heat is the main source that leads to temperature variations. Of course, there are many other factors for temperature as such, but generally we can talk about temperature variations. Then we can talk about the variations of pressure. Then we can see variations of winds as well as rainfall, right? This is the base. Now, what is El-Nino and La Nina is summarized in these 5 words itself. We just need to understand the broad conditions of that. So let us understand that. So what are El-Nino and La Nina are? El-Nino and La Nina. What are these? Atmospheric and oceanic circulations which we see, atmospheric and oceanic circulations which we see in the Pacific Ocean. Atmospheric and oceanic circulation. It is not just oceanic alone, it is also atmospheric solutions together. I am talking about El-Nino and La Nina together are atmospheric and oceanic circulations in the Pacific Ocean, where have a cascading impact, have an impact on world weather. World weather have an impact on it, right? So this is what the base you need to remember. El-Nino and La Nina are 2 phases. These are 2 phases. El-Nino is warm phase. This is warmer phase. La Nina is colder phase. And there will be a normal phase which we call it as a neutral phase. So this is what is the background you need to remember. So whenever you talk about El-Nino and La Nina, this is the background. So what are they? Actually, at the time of Christmas, you all know that fishermen venture into the oceans for capturing of the fishes. As the fishermen venture into the oceans for capturing of the fishes, what they observe is, they have observed the temperatures of the oceanic water at the coast of Peru. So we have a continent, South America. There's a country called Peru. Peru has the people of Peru, the fishermen of the Peru, have observed the temperatures at the Pacific Oceans. They observed that usually they have cold waters around the temperatures of around say around 18-20 degrees Celsius. That is what the cold water. But sometimes, unusually, it becomes warmer by a few degrees Celsius, which is having a major impact on the globe. When they have observed that the temperatures are increasing at the coast of Peru, that is what they call it a condition as El-Nino, which they observe at the time of Christmas, and that's why they call it as Boy Christ, which they observe at the Christmas. And this have an impact on terms of for around, it can vary, that impact could vary from around a few months, and it could vary even to the extent of even 18 months sometimes. So what you need to know is the temperatures at the coast of Peru, as you can see here, right? This is the coast of South America, and around the South America, you have the temperatures here. Normally, you will find a cold waters because you can see oceanic current coming from the southern parts of the continent. That is here in the southern hemisphere. This is the southern part. So this is the higher latitude. So temperatures would be much more lesser. So water is moving from higher latitude to lower latitude, indicating cold water. That is what the normal. But El Nino, you will not find that kind of, unusually it becomes warmer. That unusual warmer thing is what we call it as El Nino, and that have a cascading impact on climate across the world. This is the thing. So let us understand and decode the event of El Nino in detail. You can see this. If you see this, when you talk about the first thing you need to understand about the, before we understand about El Nino, try to understand the thing like, normal conditions, and automatically you will try to understand about the El Nino conditions as well, right? So let us understand that. Okay, what are the normal conditions? Let us have a background, and that would, the opposite would be the conditions of El Nino. For a while, forget about the conditions of the La Nina, right? So what observes? Usually, let us understand the decode the first thing. Let us understand the normal conditions. You see that this is the Pacific Ocean. Why do you think that temperatures at the coast of Peru are having an impact of the world? Because it is part of the atmospheric circulations of the Pacific Ocean. When it is having an impact of atmospheric circulations at the Pacific Ocean, 1/3 of the globe is Pacific Ocean. When 1/3 of the globe is Pacific Ocean, definitely it can have an impact across the world. That is the idea. So what happens usually is there is a cold current which comes from the south. This is what we call it as the Peruvian current or the Humboldt current, which is a cold current which you form here. Because of the cold current, you will find more cool water. And also at the coast, Peru being a tropical part, we know which wind system blows in the tropical part, trade winds. And the trade winds travel along as the trade winds move from, say, the subtropical part towards the equatorial regions as they are blowing. So in other words, these trade winds drag the cool water towards this Australia. So we know oceanic current. This is the current called as a southern equatorial current of the Pacific Ocean. Southern equatorial current of the Pacific Ocean. So when southern equatorial current of the Pacific Ocean, you see that is what you are understanding, that so there is a southern equatorial current which blows and it piles up warm water here. Now you see, understand, as the water is being piled up and all, it will have an impact in terms of the circulations of the atmosphere as well. Until now we are discussing only about the atmosphere. For example, so what have you have observed? You have observed that normal conditions, cold oceanic current at the coast of Peru. Because of this, see, now you try to understand the normalcy. Cold oceanic current at the coast of Peru, warm water dragged towards Australia, which we call it as Western Pacific Pool. Western Pacific Pool. So when warm water dragged towards Australia, which we call it as Western Pacific Pool, what will happen is this warm water is being dragged. This acts as a low pressure area, and because of that, you will find that the trade winds are very, very strong trade winds. So you can see the picture. There is a cold current coming from the south. The water is being dragged towards the south as part of the south equatorial current here. Here it is more warm water. Now, why there is more warm water? Simple. One, the latitude. These are near the equator, tropical part, more heat. And at the same time, additional factor of more warm water coming from the tropical region itself, dragging here, right? So, because of that, you'll find what? More warm water. Now, what happens to the warm water? Will it not rise? Whatever the air is there, will it not rise? This air will rise. Will it go to the greater heights in the atmosphere? Yes, until tropopause. What happens then? They circulate. So, just like Hadley cell, we have a local cell here, call it as what is a Walker cell. So, whatever the air which rises from the warm water, now it is rising from the coast of Australia. That too, it is an ocean. Will it not have moisture? Yes. If it has moisture, will it not lead to rainfall conditions? Yes. So normally rainfall in Australia is provided by a non-neutral condition, a neutral phase. That is what we call it as rainfall in Australia, not flood, rainfall. Yeah, excessive can lead to flood, but generally rainfall. Then whatever the air which rises, please understand, whatever the air which rises from Australia, as the air rises here, will it go to greater heights? Yes, until tropopause. From there it will deviate. As it will deviate into two branches, one deviates towards the coast of Peru, another deviates towards the coast of into the Indian Ocean rather, where we have the Mascarene Island. So what is happening? The low pressure which is created from here, the air rises from here and it descends into the Pacific Ocean at the coast of Peru and one towards the coast of India. This is the thing which you need to remember. So, right. Now, what is happening? So, let us see the same things again. You can see there is a stronger trade wind. The trade wind is bringing more warm water towards the coast of Australia and you will find more cold water. What is happening? You see, as the winds are dragging the surface water towards the coast of Australia, from the ground level, there will be upwelling of the cold waters and this cold water will be very nearer to the surface because of which the temperatures are usually very, very cool. So, this is what it thinks. There is an upwelling of cold water. You can see here the water is from the subsurface water, there is upwelling. We know what is upwelling, right? When the oceanic water moves from the subsurface towards the top. So, there is more cold water nearest to the surface. This is what is the normal conditions, right? So, understand this again. Low pressure area, stronger trade wind. Then what happens? You have seen Australia, air rising. Air rises from Australia, right? As the air rises from Australia, what happens? Or Australia coast, which is what is called Western Pacific Pool, more rainfall towards Australia as well as Indonesia. Now, whatever the air rises here. Now, it is part of the circulation called Walker cell circulation. So, now it is oceanic. From the oceanic, we are talking about the atmospheric circulations. So, Walker cell circulation, what happens? As the air rises, it will descend into two areas. One in the Pacific Ocean at the coast of Peru. This is a high pressure area. Another into Indian Ocean at the coast of Indian Ocean and the Mascarene Island. This is also a high pressure area. Now you see here. So temperatures at the coast of Peru, as the temperatures are cold water, you find here. What is happening to the cold oceanic current? So temperatures are cold. That is leading to warm water at the coast of Australia. Temperatures are warm. This is unusual heat wave, unequal heating. Because of this, Now you find air rising, pressure variation, low pressure here, air rising. So because of this rainfall at Australia, and whatever the air is rising, you will find that it will descend into two parts, one in the Pacific Ocean, one in the Indian Ocean, creating high pressure. For example, once you have understood this, you see here. Now whatever the air which has risen here and descended into the Indian Ocean, it has dumped into the Mascarene Islands, which we call it as. And from the Mascarene Islands will be located somewhere here, right? Not way south, somewhere here, right? It's a bit abnormal picture showing over the south. So from the Mascarene High, as you move towards India, you will see that the more high pressure here, there is a more contrast of the winds temperatures between Indian Ocean and Indian landmass, more conducive for monsoon. So normally monsoons are favored, or it is normal conditions are very beneficial for monsoons. So that is the thing, right? So then what happens during an El Nino year? Instead of cold water, you have warm water at the coast of Peru, which is unusual, right? Warm water at the coast of Peru. Now, if there is warm water, what will happen? The Western Pacific pool, which I told you, Pacific side, Western side, no, Australia. Now, the Western Pacific pool will be moving towards Australia, moving towards east. So, warm water will now accumulate towards Eastern Pacific Ocean. So what is happening? The warm water which is supposed to be at Australia, you will now find at Peru coast. Because of that, what happens? Now low pressure area is at Peru. No high pressure at Australia. Or sorry, no low pressure at Australia. So rather we will say that weakening of low pressure at Australia. What will happen? You will find high pressure conditions. If you find high pressure conditions, do you find rainfall? No. Whenever I told you that high pressure conditions, atmospheric stability, no rainfall. When the air rises, when can air rise? Only when there is greater unequal heating. During the greater unequal heating, as the air rises, then you will find the impact. So that is the thing. Then as you see, instead of air rising from Australia, now air rises from Peru, descend into Australia. So what happens there? High pressure conditions. And for India, the high pressure conditions in Indian Ocean is not strengthened. So what happens because of this? Understand the impact now. Because of this is the El Nino. What happens? Whenever you will find high pressure at the Indian Ocean and the low pressure at the Indian landmass, the difference is becoming very, very lesser. You will find lesser amount of rainfall. So because of this phenomena, you will find that there will be lesser rainfall at the India's coastline, because there will be lesser rainfall during there is a probability of lesser rainfall during an El Nino year. That is the thing. Now you see, rainfall at the coast of Australia is not there because there is high pressure conditions, not low pressure. So what we are observing here is that the unusual warming at the coast of South America is having a cascading impact of distributions of pressure and temperature across the world, which we call it as something as teleconnections. Please understand what is called teleconnections. Teleconnections are large-scale, long-lasting shifts in the atmospheric circulation that can affect much of the globe. Now imagine like a car. Imagine something like a car. For a car to run, there has to be so many things which has to be at the right place, no? Right? Be it the, be it the engine, be it the tires, be it in terms of the steering at the being at the right gear, being it around the power distribution system, whatever, you find multiple things. Also, all the four cars are very much connected to each other, right? The four tires, sorry, are very much connected to each other. Just like that, the four tires are very much connected. The pressure conditions are also across the globe are very much connected. That is what teleconnections. So large scale, long lasting shifts in the atmospheric circulations, when they are very much connected, if there is a variation here, it will have an impact across the world. So pressure conditions in Indian Ocean, pressure conditions in Atlantic Ocean, pressure conditions in that all have some kind of a broad overall global circulation linkages. That broad overall circulation linkages and the variations is what we call it as teleconnections. So somewhere temperatures at the Australia or the coast of Peru is unusual warming is what we call it as El-Nino. It can have an impact in the pressure conditions of the Northern America. That can have an impact of the pressure conditions in the Mediterranean Sea. The winds which can come from the Mediterranean Sea, say the disturbance called as western disturbances can be impacted. When western disturbances are weaker, monsoons in India, rather when western disturbances are weaker, the rainfall in the winters is very less. It can have lack of snowfall in the Himalayan region like Gulmarg. So recently, until January late January, we haven't seen any kind of snowfall in Jammu, in the regions of Jammu like Gulmarg, Pahalgam and all. The reason is simple. This year happens to be an El Nino year and last year happens to be an El Nino. We are in the phase of the El Nino right now, and because of El Nino, there is a circulations of variations of pressure, not just in the Indian Ocean and the Atlantic Ocean, in the Pacific Ocean, but also in the Atlantic Ocean, and that can have an impact on pressure distributions across the world, which led to this phenomena. So as you can see this picture, you can see here, we are only broadly discussing about the Indian Ocean and the Pacific Ocean here, but we can also have the same impact to a certain extent even in the Atlantic Ocean. So whenever there is a variations of pressure conditions during an El Nino, so you can see here El Nino, it is dry conditions India, Indonesia and Australia. India, Indonesia, Australia, dry conditions. You will find more rainfall in the Americas, especially in the Peru coast and the rainfall season here in the central Mexico. Because of this variation, the pressure conditions even in the, say, the continuation here, the Atlantic Ocean will be having a variation, and this variation will have an impact on the winds which come from the Mediterranean Sea towards India. So that is what the teleconnections is. Somewhere happening, the broader global circulations are very, very connected to each other, and that impact is what we are facing, right? So you can see here, El Nino here, instead of the air pressure which is supposed to rise at the Australia, you are seeing that it is rising towards the Peru coast, right? So this variation can have an impact on the distributions of rainfall across the world. Hope you all have understood this, right? Also, please remember, you can see here, El Nino, the warm water is dragging towards the coast of South America, right? Here cloud formation, rainfall, whereas not rainfall in the other side. So this is what you need to understand. Then one important thing, for Indian monsoon, the favorable conditions are always low pressure at the Indian landmass, high pressure at Indian Ocean. This is favorable, right? During El Nino, what will happen? During El Nino, this is normally. During El Nino, what is happening? The high pressure is not strengthened. The high pressure is not strengthened, because of which there is a possibility of variations of monsoon. That is what we call it as what? That variability, or is what we call it as vagaries of the monsoon. Now you see, what do you mean by vagaries of monsoon? One thing, imagine that there is not much of change in terms of total amount of rainfall received in India for that particular year. That remained the same, average. So there is not officially drought at the national level. But what about the district level? Any small variations of rainfall in 1 month can have a cascading impact on the water resources of a local region. Say a region like Bundelkhand in UP, or else a Chhattisgarh region, or else a rain shadow region of the Western Ghats in the Deccan Plateau, or else the dry areas of Saurashtra, the Kutch Peninsula, or else even the regions of Marusali regions of sand dunes in Rajasthan. Always they get rainfall during whatever the rainfall they get, it is always during in the monsoon season. But when you don't see some kind of rainfall across these places, and that rainfall becomes very, very less, it can have a cascading impact maybe at the state level and even at the district level. Why do you think that you are supposed to learn about this topic is it can have an impact of rainfall in our country because of this phenomenon. That is why we are asked to learn about this as a policy maker. That is the teleconnection involved here. Also, you need to understand that we have only spoken about El-Nino. What about the La Nina? Please understand that the La Nina conditions is the exact extremes of normal conditions. What is La Nina? Exact replica of normal conditions. Cold oceanic current at Peru, you will find very cold oceanic currents. Warm water dragged towards Australia, you will find cold water is more warm water is dragged towards Australia. What is the difference between the normal and the El Nino? Opposite. What is the difference between normal and La Nina? Extremes of the same normal, right? So please understand, La Nina, extremes of normal phase or strength of normal phase is dominant. Cold oceanic current, you will find very cold. Warm water, very warm water, much warm water. Stronger warm water, or what we can say is stronger Western Pacific pool, more warm water. So when you find more water instead of rainfall, what happens? It is now flood. 2022, 21, 2020 happens to be a triple La Nina year. 23 happens to be an El Nino year. While the presently we are under the influence of El Nino, and this phase might continue even for this year. We will wait and watch about the temperature conditions at the coast of Peru, which can have a cascading impact of temperature across the world. Right? This is the phenomena of El Nino and La Nina, which can have an impact of climate across the world. Hope you all have understood this. Until we meet next time, it's a goodbye to all of you. We'll come with a new topic tomorrow. Thank you for watching it. Thank you.